My name is Mary Wootters. I'm an assistant professor of computer science and electrical engineering at Stanford. My research is on the theoretical side of things. I'm broadly interested in algorithms for communication, storage, and data processing. One thing I've been thinking about a lot recently is error-correcting codes, which are a fundamental tool for protecting data from noise. So an error-correcting code is essentially a way of encoding some data, say a sequence of zeros and ones, so say you have like some sequence here, in a way that adds extra redundancy so that you can recover it even if it gets corrupted. So if we have our original data here, we might want to encode it as a longer string so that even if this longer string gets corrupted somewhere, we still don't lose the original data. One way to do this is just to repeat the data a bunch, like you have your original string and then you just copy it several times. So this works. It protects the data from noise, or at least from some forms of noise, but it introduces a lot of overhead. So now instead of storing or communicating just this amount of data, you have to, store this much, repeat it a bunch of times, way more than you originally wanted to. So one of the big questions that I think about is, what is the best way to add redundancy so that we can get the best possible trade-off between robustness from noise and the amount of overhead that you're introducing? So this question turns out to give rise to a bunch of really interesting and often really difficult combinatorial problems. And in addition to the combinatorics, of course, we're also interested typically in efficient algorithms, which makes this question space even richer. That is, how can we design these encoding functions in such a way that they both have good trade-offs between the robustness and the amount of overhead we're introducing, and also so that they admit efficient encoding and decoding algorithms, or algorithms for manipulating the data in any other way you might want to. My research in error-correcting codes ranges from the quite theoretical, so those sorts of combinatorial problems that I mentioned earlier, to the maybe slightly less theoretical. So for example, one area that I'm excited about right now is coding for distributed systems, like distributed storage or distributed computation. So traditionally in error-correcting codes, the definition of efficient, when I say efficient encoding or decoding algorithms, is in terms of the running time of those algorithms. That is, we like algorithms that run quickly. So in a distributed setting, of course, we still care about algorithms that run quickly, but we also care about, for example, the communication cost or the network bandwidth of your algorithms. So how much communication is happening between nodes, things like that. And designing low communication algorithms for error-correcting codes is an exciting area that my group's been working on a bit recently. Another thing I like to do in my research is collaborate. One of the things that I love about Stanford is that there are so many smart people working on so many different things, and for the most part, they're happy to collaborate with me and teach me about those things, even if I know absolutely nothing about them going in. And that's really exciting. So for example, at Stanford, I've collaborated on projects about coding for DNA storage. This is with Zaki Weissman's group in EE and Han Liji's group in the med school. And also on projects about algorithms for modern memory technologies like resistive RAM with Subhashish Mitra's group in EE and CS. Stanford's just this really exciting collaborative place, and it really pushes me to learn new things and to keep exploring new research directions. If you'd like to learn more about the research that I and my group are doing, you can check out my website. If you'd like to learn more about error-correcting codes, check out my educational series of lectures on my YouTube channel. Don't forget to like and subscribe. Yeah, so my favorite place in the Bay Area or on campus, well, I just really love all the nature in the Bay Area. I really like to be outside. I like hiking, trail running, stuff like that. There's a lot of really pretty trees around. I like trees.